Alright, so I think I'm recording. Let's take a look at problem number 3. It is very similar to our previous problem, but there is one difference, and that's in the numerator. In our previous problem, we had a fraction that had a binomial in the denominator, but just a monomial, a single term in the numerator. So here in the numerator I have two terms, but we start this problem the exact same way. We want to multiply this fraction by the number 1. But we have to be clever in how we write the number 1. We look to the denominator and we take what they call a conjugate. The conjugate simply takes the same terms, but it changes the operation. It changes the addition to subtraction. Now, if I have a fraction that I want that fraction to be equal to 1, the numerator and denominator need to be the same. And the numerator and denominator can't both be 0. That's the only restriction that we have. So now multiplying fractions is pretty easy. When you add and subtract fractions, you have to bother with getting a common denominator. We're just going to multiply straight across in the denominator and multiply straight across in the numerator. Now, when you're multiplying binomials together, I suggest that you do it in the form of a table. The mathematical property is the distributive property, but students can sometimes apply that property wrong, and a table is an organized way to apply that distributive property. So let's take these first two terms of the numerator and put them on the side of our table, and let's take the next two terms and put them across the top of our table. So that way, for those of you that prefer FOIL, we are doing FOIL. We're just, instead of writing it all on one line horizontally, we're writing the first two terms on the top of the top row of the table, and then the bottom. So when you spell out FOIL, the first terms, the outside terms, the inside terms, and the last terms, we're going to get the same answer. We're multiplying these together. So if we multiply the 4 times 3, the first terms of each binomial, we get 12. If we multiply the outside terms, the terms that are far away from the middle, the 4 times the negative 2, we get negative 4 radical 2. If we multiply the inside terms, the terms that are close to the middle, we multiply the negative 5 times the 3 and get negative 15. But don't forget to multiply by the square root of 3. And here, when you multiply the last terms together, the last term of this binomial and the last term of that binomial, a negative times a negative is positive, and I just have 5, and then the square root of 3 times the square root of 2 is the square root of 6. So to get my numerator, I'm going to add all of these terms together, and they're unlike. I can't combine any of these. If this was a 12 and say if this were a 6, I would just add 12 and 6 and get 18, but it's got that radical 6 there, so these are unlike terms. So the only thing we can do is just list them out. 12 minus 4 radical 2 minus 15 radical 3 plus 5 radical 6. So that's my numerator. My denominator is going to be much easier to figure, and my denominator will not have any radicals. The diagonal, when I multiply these two binomials together, will cancel because they're conjugates. That's always going to happen with conjugates. So let's see what I'm talking about. We have the 3 and the square root of 2 that we put on the left side of the table. We have the 3 and the negative radical 2. And 3 times 3 is 9. Here I have a positive times a negative, so I've got negative 3 radical 2. And then watch this, I've got positive 3 times radical 2. I've got a positive 3 radical 2. Here I have a positive times the negative, which is negative. Radical 2 times radical 2 is just 2, because that's the square root of 4, which the square root of 4 is 2. Now, we had said that because these were conjugates, this positive 3 radical 2 and negative 3 radical 2 cancel each other out. and I have 9 minus 2, which is just 7. So there's my answer. I claim that this original, well, it's not going to let me copy that. Well, hey, let's try this. There we go. That this original fraction is equal to this very ugly fraction over here. Now, we can't give a decimal as our final answer, a decimal number, but we certainly can check our answer on the calculator like we did last time. So my original fraction, I need parentheses around both the numerator and denominator because it's more than one term. It takes this binomial and it divides it by this binomial. So the calculator, to about 9 decimals, like this decimal representation goes on forever, but a fairly good approximation is that this number is negative 1.0557 blah blah blah. Alright, let's see if this next if my answer gives me the same decimal number. So my numerator this time has 4 terms in it. I've got 12 minus 4 radical 2 minus 15 radical 3 plus 5 radical 6. And I had to tell the calculator that that whole thing was my numerator. That's why I needed parentheses around it. That whole thing is being divided by 7. And if we've done this problem right, we should have the same decimal number here. And we do. So I'm fairly confident that my answer is correct here in number 3 by taking the time to check it on my calculator. It might save me, it might catch me making a silly mistake. Because it's very easy to do things like 3 times 3 and accidentally write 6 there or something like that. Or we've seen it before yesterday that I was copying numbers down and I just left out a number. It's like if I was writing minus 4 radical 2 and down here I just wrote minus radical 2. I just sometimes will just accidentally not write a number down. So you can imagine that anybody can do that. So if you take the time to have some type of a check like that on a calculator, you might catch those silly mistakes. So I hope this helps, and let's move on to the next problem.